Okay, so we are on to the last factor that affects the stability of the conjugate base. All right, and this one is called orbital. Let me show you this real quick before we talk about in the detail. Okay, so what we got here, we have a proton of an alkane, proton of an alkene, proton of an alkyne. And if you still remember the pKa table, that alkyne is the most acidic compared to alkene and alkane, right? pKa 25, 44, and 50 for alkane. Okay, how do we explain this pKa though? Well, let's take a look at the conjugate base. All right, now all the negative charges are on carbon, on carbon, on carbon. We can use the size, same size, right? On carbon, same size. All carbon have the same electronegativity. Do they have resonance? None of them have resonance. You cannot draw any arrow in anywhere. All right. Inductive effect though. Well, there's no electronegative atom nearby. It's just a carbon, carbon, carbon. Can't do anything. Well, the tiebreaker is going to be the orbitals, right? The orbitals of this carbon bearing the negative charge. All right, go back to we talked about in chapter 2 the characteristic of an sp3 orbital, sp2, and sp. Right? If you still remember that for an sp orbital in alkyne, we make one s and one p orbital. And the sp orbital going to look half s orbital, half p orbital, and s is short and fat, and p orbital is long and thin. This guy kind of chubby, all right. And for an sp2 orbital, 33% s character, so a little bit less look like s, but more like p. 66% look like p orbital, so it's longer, right? The electron is further away from the nucleus. And for an sp3 orbital, it's like in an alkane. So 25% S, so 75% p orbital. So look much more like p orbital, long, real long. All right. What I'm saying is, here's my point. Look at right here. In an sp3 orbital, the distance from the nucleus to the electron is far, compared to the distance of the nucleus to the electron in an sp orbital much shorter. See that? This guy is much closer. The electrons that are closer to the nucleus, which is have proton, this electron will be stabilized by the proton much better than the further away one. Right? The proton holds the electron much better, stabilize positive, negative. They stabilize each other well, better than the electron that's further away. Right? Which means that using the orbital effect, the lone pair in a short arm right here, short distance to the nucleus of alkyne, is the most stable. Right? This guy is the most stable among these three. All right, the most stable, of course, the alkyne become more the most acidic compared to alkene and alkane. Okay, all right, that's pretty much it. All right, let's go summarize right here on the next video.